Okay, good morning, everyone. This is Tim Terway with VCGI, here with Ivan Brown, also a VCGI, as our database administrator, who's going to give a 30-minute overview today of our SQL query tips and tricks for GIS users. So without further ado, I'll hand it over to Ivan.
Thank you, Tim. Again, this is a 30-minute webinar that provides a high-pass intro to SQL, or structured query language. The first half of it will be general overview and intro on the language, and the last half, more or less, will be for demonstrating some SQL query tips and tricks. What you won't learn here is how to use SQL to build a database management system from the ground up. What you will acquire from this webinar are some tips and tricks on making queries better and also mining data from a database in ways that aren't always so conspicuous with the dialog boxes that you see in software. So SQL, I think, is an acronym that gets misused at times. There are a lot of technical things that we have in the GIS realm and in the greater IT realm. A lot of use of the SQL acronym. There are databases that have SQL in their name, for example, Microsoft SQL Server. However, when we're talking about the core of SQL, or structured query language, we're talking about a programming language that's based on an ISO, or International Organization for Standardization, standard. The database programs that we have out there run on SQL, and often with a superset of the SQL language. They have bells and whistles, functions, and etc., syntax requirements that go beyond the core of the ISO standard. In general, the SQL language is broken down into two categories. Some of it is used to define data structure. For example, you can use SQL to create a database, create a table, add a field to a table, etc. The other area of SQL use is with operations on data, selecting data, inserting records into a table. Often software with which you interact does this for you behind the scenes. Really, much of this technical world that we're in runs on SQL. We just don't normally see it. Here's the syntax of SQL in a nutshell. SQL is it runs on statements, and a statement is like a sentence, and the sentence has pieces. At the lowest level, we have identifiers, which are objects with which we want to interact. An identifier can be a table name, a field name, a database name. Constants are, for example, the number 2, or a certain string that's saved into a variable, things that don't change throughout execution of SQL code. Operators include things such as the alligator mouths, the greater than, less than, and or. There are also some functions in SQL that dynamically evaluate bits of data with which you are working with to determine if that piece of or bit of data is going to be used. And expressions are collections of any of these identifiers, constants, operators, functions, any of these pieces combined to make an expression that, when expressed, determines if a condition is true or false. These small pieces build up portions of statements or sentence-like structures. These portions of statements are called clauses. And at the highest level, at the highest level at the line, on the line of code, we have a statement. More on the syntax. So often when we interact with a database, we want to get some kind of subset of the data in the database that meets a set of criteria. For example, we might have a database that stores information on inspections, city inspections. We might want to just see the electrical inspections and only the ones that have not yet been completed. And in order to do that, we compose a statement, or this sentence-like line of code here, that begins with a clause that begins with the select command. Then after select is a star, which is a wildcard. That's where the columns or fields that you want are listed. If you enter a star there, you're going to get all of the columns from the table. From signals what table you want to query from. Where is the beginning of a clause where you specify some operators and some identifiers to indicate what has to be true in order for a record to be returned in query results. So here we only want records with electrical in the type field and a status of, and I can't see it, I'm going to slide my go-to over, status of 0, which means not yet complete. So this statement down here is a translation of the Venn diagram that you see there. Again, at the highest breakdown of SQL, we have commands or statements that are created that define data structures, like creating logins and passwords, creating indexes on tables, deleting tables. Then we have the other category that's all about operating with data. Select is the cornerstone of commands or bits of statement that are used when querying against data. Some other data operation statements begin with keywords such as update or select into. Select into, for example, takes a selection result and puts it into a new table. Usually when you're querying against a table, you're using some form of select. Now I'm going to walk through 12 examples of using SQL to query against databases. I'm going to start with some queries that will go against a Geo Package, which is an open standard GIS data format. The Geo Package stores vector layers, raster layers, or non-spatial tables in a type of open source database called SQLite. DB Browser is my client here for writing these queries and executing them against my Geo Package. So we're going to start with something really simple here. First of all, I have the Geo Package database opened up here in this DB Browser client. And the queries that I'm going to run are going to go against this inspections table here, which in reality is a vector layer that could be used in QGIS. However, right now we're just doing some direct SQL work with the database. So getting back to the most basic of select-like operations, I'm going to simply execute a query here that gives me all of the fields from the inspections table, no other conditions required. Give me everything. And when I execute, here's the result. There are 50 records in the table. I have 50 rows returned from the query. By the way, in this DB Browser client, you can take a query result and save it as a file. and then use it somewhere else. So to take a step up into something that's slightly more complicated, let's expand the select statement a little bit and only request certain fields. So I don't want all of the fields, I only want the type field and the status field. Give me all the records, but only those two fields. Just an S. All right. And again, it gives me all 50 records. However, this time I only have type and status as requested. Well, let's step it up a little bit more in terms of complexity. So this inspections table has a type field, and as I scroll through this, you will notice how the types are entered inconsistently. Sometimes electric is all caps, sometimes it's electrical, which actually means the same thing. Plumbing in all caps, plumbing in mixed case. I want to find out, I want a result from a query that shows me one of each distinct or unique type that's in that column. What are the possible types there? To do that, I can use distinct. And I get 5 results, one for each possible value in the type field. When you want to clean up data, this is one way to quickly get a grip on how the data was entered, and then you can go ahead and make it more consistent. Let's get a little bit more complicated with some and or operation. So right here, we're going to get all of the fields from the inspections table that have a status of 0, which means that the inspection has not yet been completed. And we have some parentheses here, and just like in math, what is entered within parentheses gets executed first. So in order for a record to be returned in the result, these criteria have to be, or this criterion has to be met. The type field has to either be electric in all caps or electrical in mixed case. Has to be one of those, and the status must be equal to 0. I'll execute. I think I have to select the whole thing. Here's the result. We only have records here with a status of 0, as expected. And the query did indeed give us types that are either electric in all caps or electrical in mixed case. Sometimes in life, you know a lot about what you don't want. And that same philosophy can be applied to SQL. So if I want records from the inspections table where the status is not 1, meaning that I'm going to get the zeros, which means that it's not completed. A status of 2 means that the inspection was conducted, but it failed. I want everything except for the ones that have been completed and closed. So I'll run this. And in the result, we have records with a status of 0, meaning that it was not worked yet, and we have some failed inspections there as well. The average function is a lot of fun. So if you have a numeric column or field in your table and you simply want the average of those values, you can do that with SQL. So here I'm going to use a select statement, and I'm going to use the average function with the status field. and we're querying against the inspections table. Now, this isn't very exciting in terms of the data with which we are working here. It's sample data. The average function might often be used with dollars and cents kind of column, or some kind of metric, like a stream gauge metric, that kind of thing. However, to show you how average works, I'm doing this against this status field. And if you simply want a count of records, you don't even want to see the records sometimes. You just want to know how many records exist in the table that meet a certain condition. We can do this sort of thing here. We can use the count function. So here I'm using the count function against the city field from the inspections table, and it has to meet these criteria. The city has to either be Westmont in mixed case or Westmont in all uppercase, again, because we don't have data consistently entered there in the city field. So I want all of the Westmonts. We have 26 of them. Now, this DB browser client and this direct SQL access, it's exciting for a little while. Sometimes it's fun to get back to maps, right? So these next examples are going to be done in ArcGIS Desktop. My next example is going to be with using the upper function. So I have the inspections layer here on the map. I'm going to open up this dialog to write a query. I want to know what inspections were assigned to the employee McDaniel or to Wilson. And again, because the data had been entered inconsistently, some are all caps, some are mixed case. So as a primitive way to write that out into SQL, it looks like this. You would have to write a where clause here that requests records for assigned to McDaniel in mixed case, and then an or, then uppercase, and then an or, and then etc. for Wilson. That works. However, there is a shorter way. You can use the upper function to dynamically in the process have the assigned to field, whatever string is there, be converted to uppercase for evaluation. It doesn't actually alter the data. And also we have an in operator here. So this is indicating that once we've uppercased the inspector's name, if it's McDaniel all caps or Wilson all caps, the criteria or criterion is satisfied. So I'm going to go ahead and run this. And again, the same result. The between function is a lot of fun. So we could, if we wanted all of the application numbers or records with application numbers greater than or equal to 9020 and less than or equal to 9040, we could click through this thing, take several milliseconds to fill that out. This way, app num is greater than or equal to 9020, and app num is less than or equal to 9040. It works. However, there's a shorter way. You can use the between clause to simply say, this is the same thing. This between 9020 and 9040 means greater than or equal to 9020 or less than or equal to 9,040. I get the same result. Another fun one is the wildcard, the like operator. So again, we have data that was inconsistently entered into this inspections table. To sort through the mess, sometimes like gets the job done. So here we're going to take the type field and use like with a wildcard. The wildcard in this type of database signaled by a %sign. This is going to take every type value or string, uppercase it dynamically, and return the record to me as long as the first 4 characters are ELEC. And as you can see here, it really, really works. Dates can be tricky, but with a little practice, you can get to a point where you can query against date fields quickly. So if I want all of the inspection records for the last half of July, it can be done like this, using a between and some syntax here that signals that these are date values. I'm going to show you something about dates here. So if you're unsure about how to format dates in a query, and it does vary by database type, in ArcGIS Desktop, you can click on the date field that you're interested in, get the unique values, and see how to format the statement. So I want application date between and I'm just going to click the top string to get the format. We're going to signal that what comes next is a date value, and I want inspections or applications from mid-July, July 15th, and the end of July. So I can just pick up this string here and change this to the 31st. I'll sort through this table really quick. I'll sort on date. We're in June, then we get into mid-July, and then we have selected records. How about that? And the very last demonstration is using the Char Length function, which is a lot of fun. So sometimes you get data that has a string field, and the field is supposed to have a certain pattern, a 5-character number. And sometimes you get leading zeros, sometimes you don't, sometimes you get more digits in the field than should be there. And you can sort through the pile by using the Char Length function. So this is going to take the project number field and give me all the records where the string in that field is greater than 5. And as you can see, let's say the project number is only supposed to be 5 characters long, but somebody, for whatever reason, padded with some leading zeros here. Sometimes you're simply at the mercy of the data that you received from somewhere else. And again, with a little SQL trickery, you can sort through the pile and do what you need to do with the data. We have about 5 minutes left. I gauged it for about 50-50 between presentation and questions. I apologize for it being more heavy on the presentation side. So I'll go ahead and open up to questions. Please enter your questions into the chat box, and we will respond to as many of those as we can.
So while we're waiting for questions there, we're happy to field them. Just wanted to switch over and show you where these videos live if you want to return them after the fact. So on your screen, you should be seeing VCGI's YouTube channel, which is kind of memorable at youtube.com/VTGeospatial. You can see a bunch of videos there we posted in the past, so feel free to reach out. We'll make this available within a day or two, and you can visit some of the SQL tips and tricks that Ivan was mentioning before. Also, you might want to look at the upcoming events on vcgi.vermont.gov's homepage. That actually has the announcements ahead of time. So for example, you see here August 22nd, if and when we're going to have some of these events that we listed here, as well as on the bottom of the page, news and updates, you'll find postings of when other videos or articles are available. Feel free to look there and you'll find what you're looking for. So it looks like we have some questions, one of which was a note that we're wicked reverbery. That's good to know. So hopefully that's been sorted out. Any questions for Ivan?
While we're waiting for some questions to show up, I want to make note that what I've just shown here is really just the tip of the iceberg in terms of SQL and what it can do. There are entire courses on SQL. The database world really runs on it, and in most cases, SQL is used. There is something called NoSQL, which would be a topic for another day. If you want to learn more SQL, there are a couple of really good resources. One is a website called w3schools.com. You can go here to this site. It's free and learn a lot of SQL or even other programming languages. w3schools.com. They have tutorials for JavaScript, HTML, XSLT, and SQL, a really good site. And also the ArcGIS help system is really good on documentation for use of SQL. Not only do they get into SQL here, but they break it down by different database types. They show you how the syntax varies a little bit depending on the database that you're using.
Great. So without any other questions, thanks, Ivan, for giving us that show. And again, we'll have these posted up to our channels within a day or two. And stay tuned to vcgi.vermont.gov for more content as we announce it. And thanks a lot for joining us.